Physics Penguin.
Welcome to Physics Penguin's Guide to Newton's Laws, Part 2. Last time we looked at Newton's first two laws, so let's start by reminding ourselves what those first two laws were. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. Newton's second law is simply the formula F equals ma, where F is force, m is mass, and a is acceleration. Newton's third law is a little harder to imagine. It states that whenever two objects interact, they exert equal and opposite forces on each other. Many people use the phrase, every action has an equal and opposite reaction, but this can cause problems because it misses two important points. The forces must, number one, act on two different objects, and number two, have to be the same type, e.g. they both have to be contact forces. Let's look at a simple example. Here's an igloo. This walrus is too big to fit inside, so he climbs onto the roof. His weight is a contact force onto the ice blocks. The third law states that the ice blocks will push upwards with an identical but opposite force. So what happens? Well, the top of the igloo is being pushed down by the walrus, and the walrus is being pushed up by the igloo. So what happens? Do they start to accelerate in those directions? Well, probably not. Think about the walrus to start with. He has a weight force pulling him down, and a reaction force that we've just seen from the ice blocks pushing him up. These forces are exactly the same size but in opposite directions. Remember that forces are vectors. What thing happens when two equal and opposite forces act on the same thing? Well, they cancel out. The resultant force is zero. This means the walrus does not go up or down at all, he just sort of sits there. So what about the igloo? Well, it has its own weight pulling down, and the weight of the walrus now also pushing down. However, the ice it is built on also creates a reaction force that pushes back, following the third law. This means that the total forces on the igloo also cancel out. The igloo stays still. What if the walrus puts on weight? Well, the forces will all get bigger. In reality, the ice blocks can only cope with a certain amount of force before they crumble and the walrus falls through. Stupid fat walrus. Some examples of this law are pretty interesting. Imagine launching a rocket. When the motor fires, why does the rocket move up? Well, let's look at what's happening. Hot gases shoot out of the back of the rocket very quickly. The rocket is pushing the air behind the rocket very hard. The air behind the rocket will push back according to Newton's third law, and the rocket moves upwards. Notice that this can't explain why rockets work in space, where there's no air at all. We need momentum to explain that. This will be covered in a few videos' time. I think that should probably do for now. Let's have a go at the worksheet from the description below. Pause the video and then I will go over it when you've finished. Good luck. Welcome back. Let's have a look at the answers to the worksheet. Question 1 is the definition of Newton 3. Whenever two objects interact, they exert equal and opposite forces on each other. It's a good idea to learn these forces, I think. Question 2 wants an explanation of how the third law affects rockets. Well, the rocket sends high-speed gas out the back. The rocket applies a force to the gas, so the gas applies an equal and opposite force to the rocket. This is the idea of action and reaction making a pair. Notice the forces affect different objects and act in opposite directions. Question 3 wants the conditions that control the third law. Well, there are two. The forces must act on different objects and be of the same type, e.g. both contact forces. Question 4 is a bit of an odd one. If an object is increasing weight on a table, will it fall through eventually? Well, probably yes. It's likely that eventually the table may not be strong enough to push back with a force that matches the weight of our object. So, question 5. What's a resultant force? Well, you should know this by now. A resultant force is a force that is the sum or the total of all the forces acting on an object. And lastly, question 6. What links resultant force and acceleration? Well, let's use the second law, F equals ma. So resultant force on an object equals the mass of an object times the acceleration of that object. So doubling the force will double the acceleration. So that's our link. Well, that's it for this week. Don't forget to check back for a new video next week. Until then, this is Physics Penguin saying ta-ta.